For decades, China's government has reshaped the country with dramatic displays of state power.
From high-speed rail and soaring bridges, China is building infrastructure projects at an unprecedented scale and pace.
While engineers in Europe and America are still sketching blueprints and arguing over permits, China has already finished the project. A 640-ton beast is creeping across the Chinese skyline right now, and it's doing something that shouldn't be possible. This machine hangs in mid-air, grabs massive bridge segments weighing hundreds of tons, and assembles them piece by piece while suspended above valleys so deep you can't see the bottom. And here's the kicker. It's building the very bridge it's standing on. They've built an entire railway bridge cutting travel time from 12 hours down to 3. They've constructed highways through mountain ranges that were considered impossible to cross. And they're doing it all with machines that most countries didn't even know existed until recently. The truth is, China has been playing a completely different game, and the rest of the world is just now realizing how far behind they've fallen. Let's talk about the machine that started it all, the one they call the Iron Monster. This contraption weighs as much as 4 commercial airliners combined and stretches nearly 300 feet from end to end. When traditional cranes throw up their hands and admit defeat, this is what gets rolled out. The engineering behind it is brilliant in its simplicity. The front section extends forward, reaching out until it connects with the next support pier. Once it locks into position, the real magic begins. An entire bridge segment, not some small piece, but a massive section spanning from one pier to the next, gets loaded onto the machine. Then, using a system of hydraulics and precision controls, the Iron Monster lifts this segment into place and secures it. What makes this revolutionary isn't just the size or the weight capacity, it's the speed. Normal cranes have to reach all the way down to ground level, grab a piece, lift it up, position it, then go back down for the next one. The Iron Monster eliminates all that wasted movement. Everything happens at bridge level, which means the workflow never stops. And once that section is complete, the machine doesn't need to be disassembled and moved by trucks. It has 64 wheels that rotate in every direction, allowing it to drive itself to the next section. Think about that for a second. This thing is the longest land vehicle ever built by human hands, and it can move itself across a partially completed bridge at 3 miles per hour while carrying thousands of tons of weight. That might not sound impressive until you remember this isn't a sports car. It's a mobile construction factory that's taller than a 2-story building and wider than a 3-lane highway. China deployed this monster on the Yibin-Guiyang Railway Bridge, a project that transformed travel between Sichuan and Guizhou provinces. Before this bridge existed, people had to take winding mountain roads that stretched the journey to 12 hours. Now, 3 hours, and you're there. The Iron Monster also played a crucial role in the Belt and Road Initiative, helping China recreate what the ancient Silk Road accomplished centuries ago. In regions where valleys drop thousands of feet and conventional construction methods would take years, this machine made the impossible routine. When the terrain gets too difficult even for the Iron Monster, when the path forward goes straight through solid rock, China brings out an entirely different class of giants. Less than 20 years ago, China didn't own a single tunnel boring machine, not one. Every time they needed to dig a tunnel through a mountain or beneath a river, they had to rent equipment from Germany, Japan, or the United States. And that meant paying premium prices for machines that weren't even designed for Chinese terrain. The transportation limits meant they could only get smaller models, which made projects take longer and cost more. But China doesn't stay dependent on anyone for long. While they kept renting foreign machines to maintain their construction timeline, the government quietly assembled teams of engineers and gave them a single mission: build a Chinese tunnel boring machine that outperforms everything else on the market. 2008 was the year everything changed. China unveiled its first domestically produced TBM, and while that initial model was modest, specialized for specific terrain and limited in scope, it proved the concept worked. They weren't just copying what Germany or America had built, they were reimagining the entire concept. Within a decade, Chinese TBMs weren't just competitive, they were superior. More versatile, capable of chewing through rock, dirt, clay, and mixed terrain without breaking stride. More efficient, completing in days what took foreign machines months to accomplish. And significantly cheaper, which meant more countries could afford them. The records started falling like dominoes. In 2016, China built the world's first TBM powered by a permanent magnet motor system. Just 8 years after producing their first machine, they were pioneering technology that no one else had even attempted. Then came the Shanghai TBM, and suddenly the word massive needed a new definition. This machine has an excavation diameter of 54.5 feet. It stretches 475 feet in length and weighs 5,000 tons. This beast is currently boring a tunnel beneath the Yangtze River to create the world's longest underwater highway. To make that possible, Chinese engineers equipped it with a pressure-balanced cutter head that adjusts automatically based on the terrain it encounters. A monitoring system tracks wear in real time and modifies drilling pressure to prevent damage. But the Shanghai isn't even the most impressive part of China's TBM story. Engineers at the China Railway Construction Heavy Industry Corporation have been working on something that sounds like it came from ancient mythology. They're building a TBM that will be twice as heavy as the Shanghai. The problem they faced was fundamental physics. The bigger a TBM gets, the more force the surrounding earth and rock exert on its body. Eventually, you reach a point where the machine simply collapses under the pressure. No amount of modern steel could solve that problem, so Chinese engineers looked backward instead of forward. They studied the sword of Gujian, an ancient bronze blade from 496 BCE that's still in pristine condition today. The secret to its durability was a blacksmithing technique where heated metal was cooled using clay instead of water, creating a more controlled temperature change that dramatically increased toughness. Chinese engineers adapted that 2,500-year-old technique to modern metallurgy, creating TBM components strong enough to withstand the forces that would crush conventional machines. The result is a boring machine heavier than the Eiffel Tower that can dig longer tunnel sections without any structural concerns. China also pioneered rectangular TBMs, which create tunnels that don't need extensive finishing work and make better use of available space. 7 out of every 10 tunnel boring machines working anywhere on Earth right now were made in China. That's a complete reversal in barely 17 years. Countries that once exported TBMs to China are now buying Chinese machines because they're simply better. And if you think that's impressive, you haven't seen what China built to reshape entire coastlines. Before we continue, if you're fascinated by these impossible engineering achievements and want to explore more forgotten marvels from around the world, make sure you subscribe to The Forgotten Depths. We dig deep into the stories that slip through the cracks of history and bring you content you won't find anywhere else. Hit that subscribe button and join us on this journey. The MV Tiankunhao doesn't look like a weapon, but its looks are deceiving. This ship is 460 feet of pure engineering power, built for one specific purpose: creating land where none existed before. The concept sounds simple enough: lower a dredging arm to the seabed, suck up sand and sediment, then pump it out somewhere else. But the scale at which the Tiankunhao operates transforms this simple concept into something almost supernatural. This machine can excavate 6,000 cubic meters of material every single hour. That's enough to fill 2 Olympic-sized swimming pools in 60 minutes. And it doesn't just collect this material. It can blast it through pipes over distances exceeding 9 miles, depositing it exactly where Chinese engineers want a new island to emerge. Other dredgers can pump sediment maybe 2 or 3 miles. Other ships might manage a few hundred cubic meters per hour. This one does 6,000. The difference isn't incremental, it's revolutionary. What takes competing vessels weeks or months, the Tiankunhao accomplishes in days. China officially claims they need this ship for coastal restoration, erosion control, and supporting offshore construction projects. International law states that whoever controls an island controls the surrounding waters and seabed for 200 nautical miles in every direction. And in the South China Sea, where multiple countries have overlapping territorial claims and vast oil reserves have been discovered beneath the waves, the ability to create new islands isn't just about engineering, it's about power. China has ongoing disputes with Vietnam, the Philippines, and Japan over these waters. By deploying the Tiankunhao to create islands in contested areas, China effectively manufactures sovereignty. They're not conquering territory through military force. They're literally building it from the ocean floor, one pump load at a time. fitting a pump powerful enough to move 6,000 cubic meters per hour, a dredging apparatus that can reach extreme depths, along with all the support equipment, crew quarters and control systems, into a 460-foot vessel required engineering precision that most countries simply cannot achieve. This isn't just a ship with a pump attached, it's a floating factory that produces islands instead of products. The arm at the front extends deep beneath the waves, and the rotating cutter head breaks up compacted sediment. The slurry gets sucked up through massive pipes, processed to remove excess water, then shot out at high velocity toward the designated location. Layer upon layer, hour after hour, until a sandbar becomes a reef becomes a shoal, and a shoal becomes an island capable of supporting buildings, airstrips, and military installations. The geopolitical implications are staggering. You have to admire the sheer ambition of building a machine that can reshape geography itself. And when China needs to move the materials for these mega projects or lift components that weigh as much as small buildings, they've got that covered too, with cranes that make everything else look like children's toys. China builds cranes that rewrite the physics textbooks and force engineers worldwide to recalculate what they thought was possible. Let's start with the XGC 88000, because calling this machine a crane feels like an insult. Standing over 470 feet tall and weighing 5,350 tons, this crawler crane holds the world record as the largest self-propelled ground vehicle by gross size. When you see it in person, your brain struggles to process the scale. It looks like something that should tip over, collapse under its own weight, or require a crew of hundreds just to operate. Instead, it lifts 4,000 tons like it's picking up a suitcase. This crane gets deployed when standard equipment would be laughable, when you're installing wind turbine components at heights that give eagles nosebleeds, or when you're assembling sections of skyscrapers that weigh more than the entire crane fleet most countries own. And despite its enormous size, the XGC 88000 can be disassembled and transported to different job sites. Chinese engineers designed every component to be mobile, turning this giant into a tool that can work anywhere it's needed, rather than a permanent fixture that sits idle most of the time. But if you want to talk about pure lifting power, we need to discuss the Typhoon. In a single lift that secured its place in the record books, the Typhoon hoisted 20,133 tons. That record still stands, and it's not even close to being challenged. China built this monster primarily for shipbuilding, and it revolutionized the entire process. Instead of assembling ships from thousands of small pieces over months or years, the Typhoon allows engineers to build massive sections in separate facilities, then stack them together like building blocks. A process that used to take 2 years now takes 6 months. And then there's the Honghai crane, constructed in 2014 and still operating at full capacity today. This gantry crane stands over 400 feet tall and is rated to lift 22,000 tons. When you add the 11,000 tons that the crane itself weighs, you're looking at 33,000 tons of total weight moving along rails when this machine operates at maximum capacity. The precision needed to ensure the crane remains balanced and stable while carrying weights that could flatten entire buildings is mind-boggling. For offshore projects, China built the Zhenhua 30, which is less a crane and more a floating construction platform that happens to have a crane attached. This ship can lift 12,000 tons in a single operation, and with its hoist system fully deployed, that capacity increases to 13,600 tons. China used the Zhenhua 30 extensively during construction of the Hong Kong-Zhuhai-Macau Bridge, particularly for the underwater tunnel sections that required components to be lowered with millimeter precision in ocean currents that would topple lesser equipment. The workhorse of China's crane industry, though, is the XCMG XCA 4000. This wheeled crane reaches heights of nearly 560 feet and can lift 4,000 tons. What makes this model special isn't just its capabilities, it's its versatility. China has been using these cranes to install wind turbines across the country as part of their push toward renewable energy. It has no problem lifting the 28-ton blades to heights exceeding 530 feet for attachment. These cranes aren't just staying in China either. Countries around the world are importing them because when you have a job that absolutely must get done, and failure isn't an option, Chinese cranes are increasingly the only answer. Modular construction sounds boring, until you watch a Chinese company build a 10-story apartment building in 28 hours. Not the framework, not the shell, the entire building, walls, windows, plumbing, electrical systems, everything. How is that possible? China has transformed modular construction from an experimental technique into a perfected art form. The concept is simple. Build sections of a structure in a controlled factory environment, transport them to the construction site, then assemble them like massive Lego blocks. Factory construction eliminates most of the variables that slow down traditional building. Weather doesn't matter. Material deliveries can be scheduled precisely. Quality control happens at every stage rather than during final inspection. And because everything is built to exact specifications using computer-controlled equipment, the pieces fit together perfectly when they arrive on site. The same company that built the 10-story building in under 30 hours later constructed a 26-story skyscraper in just 5 days. 5 days for a building that would typically take 8 months using conventional methods. The real-world test of modular construction came during the coronavirus outbreak. China needed hospital capacity immediately, not in 6 months, not in 6 weeks, but now. They built a 2-story, 1,000-room hospital in 10 days using modular construction techniques. Every room was prefabricated with medical gas lines, electrical systems, and ventilation already installed. Sections arrived on trucks, got lifted into position by cranes, connected to adjacent modules, and within days, you had a fully functional medical facility treating patients. That hospital saved countless lives simply by existing when it was needed most. Companies are now selling complete modular homes that can be ordered online and assembled on your property. You're not getting a prefab shed. You're getting an actual house with proper insulation, modern appliances, and construction quality that meets or exceeds traditional building standards. The cost is significantly lower because factory efficiency reduces labor expenses, and the timeline from order to move-in can be measured in weeks instead of months. For humanitarian crises, disaster relief, or rapid urbanization, modular construction is proving to be a game changer. But China isn't stopping there. They've taken the next logical step and started 3D printing entire buildings. Giant robotic arms controlled by computer programs lay down a mixture of cement and construction waste layer by layer, building walls, foundations, and structures without human hands ever touching the material. These aren't novelty projects or experimental prototypes. China is using 3D printing for actual homes, commercial buildings, and infrastructure. One Chinese company printed 10 full-sized houses in a single day, complete houses with windows, roofs, proper foundations, not empty shells waiting for finishing work. The buildings perform exactly as well as traditionally constructed structures. They're durable, they insulate properly, they pass all safety inspections. The difference is the speed and cost. A construction site that would normally require a dozen workers can be operated by one person who monitors the 3D printer and refills materials as needed. China built the world's tallest 3D printed building. They constructed Boulder Park with every structure 3D printed. And now they're working on their most ambitious project yet, a 590-foot dam that will be entirely 3D printed. And for the projects that need traditional concrete, China has perfected the art of getting it exactly where it needs to go. The Zoomlion Sea Boom Pump stands 330 feet tall, allowing it to pump concrete directly to the upper floors of most buildings without any additional equipment. For taller structures, China developed line concrete pumps that use reinforced tubes to deliver concrete to truly staggering heights. Chinese companies successfully pumped concrete to the top of Building 117, which stands 1,957 feet tall. That's not a typo. They pumped concrete nearly half a mile into the sky, setting a world record that highlights just how far ahead China has pulled in construction technology. Everything we've discussed so far, the massive machines, the innovative techniques, the record-breaking achievements, that's just the foundation. China is building something bigger, a completely automated construction industry where artificial intelligence and robots handle every aspect of building from design to completion. This isn't a distant future scenario, it's happening right now. Chinese engineers are integrating AI into every phase of construction. Computer systems analyze terrain, optimize building designs for structural integrity and cost efficiency, and create construction schedules that maximize productivity. But AI handling the planning phase is just the beginning. China is pairing artificial intelligence with autonomous machinery to create construction sites that require zero human presence. New models of excavators, cranes, and heavy equipment come equipped with remote control capabilities, which Chinese companies are linking directly to AI systems. These machines can execute entire projects without human operators. They communicate with each other, coordinate movements to avoid collisions, and adjust their behavior based on real-time conditions. The Yangkou Dam, one of China's most ambitious current projects, will be built entirely by AI-controlled autonomous machinery. No human workers directing traffic, no foremen shouting instructions, no operators in crane cabins. Just machines working in perfect synchronization to build a massive dam. For tasks that still require more delicate work, bricklaying, plastering, concrete finishing, China has developed specialized robots. These aren't simple machines that repeat one motion. They're sophisticated systems that can adapt to varying conditions, correct mistakes in real time, and work continuously without fatigue. Robots can now lay bricks faster and more precisely than human masons. They can plaster walls with perfectly uniform thickness. They can finish concrete surfaces to specifications that would take skilled workers hours to achieve. Chinese companies are manufacturing these robots at scale, and construction firms are deploying them across thousands of projects. The benefits are obvious. No workplace injuries, no human error, no labor disputes or scheduling conflicts. Projects can run 24 hours a day without breaks. Quality remains consistent from the first hour to the 1,000th. But there's an uncomfortable question that nobody wants to address directly. What happens to the millions of construction workers whose jobs these machines are replacing? China is pushing forward with automation because the efficiency gains are too massive to ignore, but the social implications are staggering. An industry that once employed armies of workers could soon operate with skeleton crews who simply monitor systems and perform occasional maintenance. The construction industry has always been labor-intensive. Now China is proving it doesn't have to be. And once they perfect these automated systems domestically, you can bet they'll start exporting the technology. Countries facing labor shortages or rising construction costs will find Chinese automation systems extremely attractive. The question isn't whether this technology will spread. It's how quickly, and whether other countries can develop their own alternatives before Chinese systems become the global standard. China went from importing every tunnel-boring machine they needed to dominating 70% of the global TBM market in less than 2 decades. They went from building modest infrastructure to constructing bridges, tunnels, and buildings faster than anyone thought possible. They've created machines that can make islands, lift weights that seem impossible, and build entire hospitals in days. And now they're automating the entire construction process, pushing toward a future where human workers are optional rather than essential. Engineers around the world aren't just impressed, they're racing to catch up. The question is whether they can close the gap before it becomes insurmountable.